Hi, I'm Matt Casey, data science content lead at Snorkel AI, and I'm here today talking with Hoang Tran, who is a research scientist also at Snorkel AI. Hoang, would you like to introduce yourself a little bit further?
Yeah, thank you so much, Matt. Really appreciate to be here. So I'm Hoang, currently a research scientist at Snorkel AI, as Matt mentioned. I've been with Circle for I think 2.5 years. And before Circle, I had my own startup called Visly, which I was focusing on AI, especially with supporting designers to be more efficient with their workflow. And yeah, besides work, in my free time, I'm also a lecturer at VietAI, which is a nonprofit that's focusing on AI education for the Vietnamese community. So to embrace and empower the AI talent in Vietnam.
So, we're here today to talk about a project you did recently, a couple of months ago now, where you built a model that topped the AlpacaEval Leaderboard using a novel DPO and model supported approach. Can you give us the high level of what happened there?
Yeah, of course. So that approach was built upon the core idea of if you want your base model is very strong, but then it might not be the best one to further align with the human preferences. So what the core idea in that project was, we want to align it better to human preferences. And the way we do that in the typical way that, ChatGPT and OpenAI and many different companies have been doing was reinforcement learning from human feedback. There's a new paradigm called DPO, and we excited to see how that would work out. It's slightly different than reinforcement learning from human feedback, but that's like a lot promising. So that's where we adopt that technology, and it's some of the programmatic approach that we usually do at Snorkel. And happily, it was I think second place on the leaderboard at that
Yeah,
time.
second place behind GPT-4, which is the model that they're all measured against. So effectively first place, right?
Yeah, yeah, that works.
Okay. I want to pause on DPO because when you were working on this project, and we're all talking about it internally, there was a lot of discussion about the difference between DPO and RLHF. Can you dive into that just a little bit for me?
Mhm. So reinforcement learning at that piece is known to the field as like has some instability at some point. So it's also harder to steer. But that's one piece related to computational, because with reinforcement learning, what you do is you iterate your model in the loop. So you have to actually you have to generate responses, evaluate everything inside the loop of your training process. So that requires you have to have a copy of your model or like some reference, and then also have your active reward model. In that case, the evaluator. It's also the loop. So all of that in the loop. So you are incurring the generation time during the loop. You are incurring the inference time of the reward model. So your GPU is like sitting there waiting. So DPO comes in because DPO do most of the things beforehand, and then just jump directly into the optimization phase. So there's a lot more optimization in that case as well. So that's like just some component of like why DPO for us at that moment was very stable and very efficient.
We do a lot of things that are LLM related at Snorkel, but this was not exactly directly in the main line of your work. So, what was it that inspired you to check this out?
So we have a strong belief, which is metadata means meta model. And what is metadata is a very interesting concept that no one actually really like, defined. When you do like instruction tuning, or if you have like some existing data, what constitute as good data? And this excitingly was a project that we done with the Together AI team. So what we built is we built a reward model in order to determine essentially what data is good and what data is bad. And we want to actually training on a subset of data that is higher quality. The model actually trained better and becomes, I think, like 24% better compared to its original model, which trained on like all of the data. So that's where you see the power of the better data.
I recall flogging that project pretty hard. I think you started with 20,000 instruction and response pairs, and you cut it down to 10,000, the best 10,000.
Yeah. Mhm. Yep. But imagine if you have a larger data set, it's actually the same. If you do like manual filtering, like some human just come in and say, oh, this is good, this is bad. Now your scale become much larger and you have like need more human resources. If you have an automatic approach like we did, and me and my colleague Chris did that thing, and I think like less than a day, much faster than any potential human evaluators a team can do. But that also approach, if you have larger data set, then you have like, if you do the same approach, auto filter down to like 10K, you probably would have a even higher 10K than the original one. Very little human evaluation, human resources, only a computational component there.
I think we went a little bit off the path because we were talking about where the idea for this project came from.
Tying back to reinforcement learning from human feedback, The only thing you need was a prompt and the reward model. The thing is, if you do reinforcement learning, the only thing you need is a prompt. But we're interested in doing DPO as well. But for DPO, what you do is you already have a preset presence data, which is the good data and the bad data, like the good response and the bad response. But that data is very hard to find in the wild. Like there's no one that actually sitting and write, this is a good response, this is a bad response. So what we did was we self-generate response, and then we use the reward model to rank it.
So what you did is you took your limited data set of good data, bad data to build a preference model that would say this is good, this is bad, and then you had the model generate responses that your existing reward model gave a thumbs up or a thumbs down. Is that right?
Yep, that's correct.
Okay.
And why is that powerful? Look at bigger picture, because in enterprises, you probably would not have people just writing this is good and this is bad for you and like as a preference data. So if I want some have to write that in a mass scale of data, that's really inefficient.
Just give me the quick bullet list. What challenges did you run into putting this project together? I mean, obviously there's the large structural challenge of everything that you described of why this was necessary, but when you decided to go from, okay, I have this idea and I want to build it, what was in the way?
Everything was perfect, nothing in a way. It's just like one flawless trial run. Definitely that's not the case. But we faced our issue. So first, because we have a web model, we also attempted the reinforcement learning pipeline. That were very unstable in a way. Our model just become saturated and become unusable. So that's what something happened. So that's when we slowly steered toward DPO for the stabilization. But then another thing is the reward model we built was very specialized. Every of our customer enterprises, we usually build reward models to determine like good data, bad data. But you can imagine those are like very specialized to the use cases. In this case, we use the reward model from the Allen AI Institute, which is called PRM. And always, if you work with AI these days, GPUs is always another component.
So the outcome of this was you got on the leaderboard, but then what?
In the leaderboard, added a little bit of the length control component. So admittedly, the model we have originally has a little length biases due to, I think, the reward model component. So we acknowledge that, we see that happening. So we actively, at that time, also we open a GitHub repo, GitHub issue to discuss with the AlpacaEval leaderboard on the evaluation side. So we're interested in like fair evaluation. So that's why we contacted the authors and see, is there any way we can contribute to the metrics control?
So your feedback changed how the whole leaderboard, including your model, was evaluated. Is that correct?
That is correct. And we ranked lower after that iteration, but I think that's fine, because for me, I think it's better that we do fair evaluations and also demonstrating approach that we can bring the field forward and not just like hacking some reward.
It's good to advance field. What is next on the roadmap? Like you did this great thing and apparently changed how everything is evaluated. What comes next?
We have a lot of things on the roadmap for our research team. My colleagues are working actively on how we can incorporate more details, more information to the pipeline. So all of this we do, we are a research-led company, but we don't just do research for fun, definitely. All the research is trying to bring back to the platform, Snorkel Flow, to democratize and bring it back to our customers. We actively try to work with them to try to align their model better into internal policies. You can think about, like, for example, insurance or finance. Like your model cannot give financial advice ever. So that's something we're actively working with our customer on.
The whole purpose of Snorkel is to not require SMEs to label tens of thousands of rows of data. So how would this thing that you did for a generalized model work within doing a specialized model for an enterprise?
It's all come down to the workflow, right? And the data. Only you and it's a subject matter expertise in your company know about what is good and what is bad. In enterprise settings, the workflow would be you are the one who's thinking, oh, what is the behavior that you want your model to demonstrate? What are some fair access you want? What's the bad behavior that you doesn't want? That's how we start curating the reward model. So then in that case, after you as an expertise in your field, in your data, understand and demonstrating what is good and what's bad, we then compile that into a reward model or a model to demonstrate, to approximate what is your preference, can then go and then steer any language model you have. So having one model to steer another model into the right direction is how the workflow would go.
So I think we covered all of the questions that we had written down, but as we've been talking, are there any other things that occurred to you that I should ask you about? Or basically, what would you like to talk about that we haven't talked about so far?
I want to talk slightly about reinforcement learning versus DPO, the approach we take is slightly different than the original work.
Mhm.
So reinforcement learning, you depend only on the prompt. So you have a lot more creativity there. But for DPO, the original DPO paper by the Stanford team, great paper, was only focusing on the preference data. So they assume that the preference data is already curated. So that's like good demonstration, bad demonstration. And they try to make it look closer to the good one and look further away from the bad one. You lose slightly a little bit of creativity there because now you have something you try to steer toward. In reinforcement learning, the only thing that constrains you is the reward score, which is one score. In this case, you're constrained by the actual response
Mhm.
with a self-generation. So you don't lose that creativity because the prompt is the only thing you need. So your model can be as creative as it wants. It can go off the rail if it wants.
So you said creativity a few times. Could you define
Hmm?
that term?
The model can create like some extra behavior that does not look like your training data, but it can just happen. You might not say thank you in the training data, but it can happen to say thank you. But it's really highly get rated by the reward model because it's a good behavior.
What you're talking about with creativity is when the model does things that are outside of the bounds initially defined by humans. That's what you mean?
Yeah.
Okay.
Mhm.
All right.
Yep.
Well, Huang, thanks for coming. I'll talk to you again soon.
Thank you. Appreciate it. Bye
Bye.
bye. Thank you.